Take some few moments.
Sure.
Yeah.
We're live.
Yeah, we are finally live. So,
Yay.
yay.
Hello, everyone, and welcome.
Hello. Welcome to this Saturday stream. I hope you feel yourself good at this morning with XTechnology. We are trying to cover something new every Saturday morning. It's hard sometimes, but we do everything to do it easy for everyone. So yeah, let's start, Mila.
Yes, today we have ultra beginner session to clear something for real beginners. So what would be if you might wondering where to go, what to learn, why, and things like that, to clarify what are like aspects of web development and data science. We have super experienced web developer here and a data scientist. So we will try to clarify some things. And you can feel free to ask whatever you want in chat.
Yeah, thanks for that introduction. Yeah, I know probably pretty much nothing about data science. I mean, I know the concepts, but as a web developer, for me, this data science and all kind of science is something like probably magic happening when you study your models, you do something, and then these programs start giving you some results based on magical black box. And for me, it's quite complicated to understand how is it all this happens, because I'm the person who intended to write some code, and I understand this logic, and so this logic will be executed. So how was your first impression about data science? How basically you came to this area at all?
Well, I was always interested in statistics and numbers, and I was always thinking of what is going on in all these programming things. But that hard coding, when you explicitly say what program should do, and then just watching program doing that, was not that interesting for me. So I like that factor of surprise here. So you never know at the end what will happen. You have some suggestions, maybe the way you expect things that might happen, but at the end you are almost always at least a bit surprised. So I like that factor of surprise. I ended up in data science world by accident. I started with bioinformatics. Turned out that nothing was really there. So in my PhD thesis, I should cover something. And it turns out there is nothing to be covered by bioinformatics. And then I have some data which I should combine. And then we said, why not data science? And step by step, I got really deep into it. And now it's kind of really broad area that the data science is covering. So we'll talk about that maybe later.
Yeah, I have also two stories about data science I've experienced. Yeah, first story is related to my previous job. Basically, on this at this company, we were doing data science on top of non-personal data of visitors of the websites, and basically based on this data, we were predicting how good or bad not this person, but this device from which was the visit happened. Basically, yeah. So I've been doing there mostly web development, like backend, front end, and stuff like that. And then there was some extra stuff like data science, and for me it was and still is like a black box. You pass some parameters, some magic is happening for a few seconds, and it returns you all these predictions. And yeah, that kind of interesting things, I would say.
Yes. And actually, the code is really simple. And for developers, it's quite surprising things. What can you do with few lines of code? But actually, there is a lot of statistic going on behind it. And if you don't include all that math and statistics, then you can just do some weird things that wouldn't really work in reality.
So
And actually, there are some ways now to unpack those models and to see what is going on inside them. So it's not that black anymore, and it's whole area to be explored. That
so you
explainability.
do so you do all these things based on Python or some other technology.
Sure. When you want to start, the safest place is Python. You can start with R. I heard of some examples doing that with Java. You can do some TensorFlow with JavaScript, but Python is like the broadest place and like the most common place to start and to
I've done some TensorFlow, by the way.
really.
Yeah,
Whoa.
they have a partition from TensorFlow, like TensorFlow JS. So
Yes.
it basically opens you to run this technology pretty much on any language, which is quite nice. And yeah, we've done some face recognition stuff, which was really incredible things. I mean, we just used pretty much existing technologies, and right after that, you can basically take some amount of points from your face, and basically the idea that you don't save even picture anywhere, so you save only these points, and then you can, for example, show a passport or whatever else ID, and take the same points and compare these to each other, and basically predict how these two persons are the same or not, kind of.
Yes. TensorFlow JS is really mighty in that deep learning. So things like images, because it's not sending data somewhere to the back and then sending it back to your browser, but everything is happening in the browser, right?
Yeah, exactly. That was the main idea. However, it also has some disadvantages. So basically, we had two ways to do that. This data science, because we were intended not to use and not to save any personal data, including personal images, to anywhere. So we were going to do all this stuff only on the front end. And one way was to use technology called WebAssembly. Basically, it's some web technology which allows you to run any backend or whatever language in the browser, or go the path with TensorFlow. But both ways, the disadvantage that you have to load in the browser very huge models, about 10 megabytes or even 40 megabytes. So you can imagine if you are sitting in the village on the phone, you are not really able to load 40 megabytes there to just do a scan of your face.
I think we even have a separate session on web assemblies. One of our first
Yeah,
sessions, Alex
yeah,
talked
we've had
about
it
it.
with Alex. Yeah.
Yes. So that were some, let's say, experiences or fun stuff. But let's maybe go for beginners to some basic terminology. So I never actually knew the difference between programming and development. Is this development just fancy way to say programming, or it involves something else, something more?
Uh, it's
Or
it's
it depends.
it's really a good question. I don't really know the maybe right answer, and I just will follow my mind on this path. I mean, for me, it's pretty the same programming, but programmer is kind of a word which just harder to pronounce, but development, maybe it's a much broader term. So if I Google like developer or development, usually I see in the Google results coming from building construction or something like that. So they are mostly called developers. And for me, it's strange because I mean I really used to feel this term only related to like software development, but it's really not. For me, it's just easy in pronunciation and easy to understand, developer development compared to programming and programmer.
It's not connected with the code itself. So it's not maybe the thing that programmer is writing the code and developer is using all that in some more complex infrastructure. That was the way.
You may be right on this path. Yeah, I mean, programming, it's something related to the code itself, and developer, it's something about creation of something. It's not really related to the code. You can create it. I mean, there are tons of tools right now, and those tools allow you to create websites, create whatever you want with no code. Basically, deploy it with no code, run it with no infrastructure, like serverless functions and the stuff like that, with just few clicks. And all these guys who create this, they also call themselves developers. But basically, they create something, but they don't really write code at this point.
Oh, so there is codeless development.
Yeah, and recently, by the way, GitHub announced a tool which called CoPilot. I'm not sure have you heard of this or not. So basically, the idea of this tool, it's an IE which just follow how you and your team write in the code inside the company, and then it suggests you to insert some certain blocks. So basically, you just started writing function name like function, for example, called download tweets. And when you write these, it suggests you to insert the whole code block to download tweets from Twitter, and basically you just go over and write business logic after that. But all these simple things already suggested to you by this IE.
Whoa.
Yeah, pretty dangerous and strange feeling when you can finally be replaced by IE, which you could develop actually.
Maybe not so fast. So maybe the fun thing about data science and code is that you can spend forever. You can spend few years at the beginning in Jupyter notebooks, and then you write their simple codes, and no developer will understand you. How can you just live in Jupyter notebook, and what kind of coding person are you if you are doing everything in Jupyter notebook? At some point, you do move your models when you find something into production, and then you actually cross the development. So then you put your models somewhere interacting with something else. And then the really crossing point would be maybe that monitoring thing. You do monitor your applications, right?
Yeah.
Yes, we do monitor our models and data.
Oh, you too.
Yes,
And I actually have a question. Maybe you can clarify about this
sure.
terminology. Maybe not sure how it's called on your language, or on your data science language.
Okay.
But I know that there are two ways of to study your model. So first, way is called something like studying with teacher. So when you ask model something and then you give it an answer as well.
Yes,
And
supervised learning.
yeah,
And
nice. And another one, basically, uh, again, not sure how it's called. It's something when your models study based on already existing data without your supervising. I don't.
unsupervised learning, yes,
Yeah,
without
and
answers, labels,
can,
examples.
can you clarify where it usually used, both of them, and what basically advantages and maybe disadvantages of each?
Well, you use completely different algorithms for those two. Uh, you usually use that unsupervised learning when you want to explore the data. You don't know maybe even what you are exactly searching for, or you don't have answers yet. So you maybe have some group of people, you don't know how to group them in
Mm-hmm.
similar groups, have no idea how to distinguish those, and then you do that unsupervised supervised learning without answers, examples, labels, whatever. And you if you already know, I don't know, if you want to classify type of birds or whatever, then you provide the algorithm with answers. So depends on the problem and logic you are solving.
Yeah.
If that's not clarified, ask me some more.
Yeah, I just trying to remember from my past. I mean, in the university, I studied in the university, and we had a lot of software related topics, including statistics. And I mean, but basically, this subject about statistics was only math, no coding. And by the end of the basically this course, you have to already start exploring some coding and applying this math knowledge. But for me, yeah, it was too boring to be honest. I don't know why I just cannot load so much math in my mind. Yeah, but then later we had a lab when we should study. I think it was I wrote this on PHP, and the idea was yeah, supervised studying. I think based on neural networks. When you provide some images, like it was like 1, 2, 3, 5 till 9, and then and you say to this network, what is that? Then you start to rotate this image, and again you say what is that? And then you again rotate this image and add some noise, and again you say what is that? And then finally, after 74 hours of study in this model, you can ask, uh, basically giving it almost any image and asking what number is that. And that was really great example for myself, and basically first and maybe the last example I really dive into this data science stuff very deep. I mean, for me it was very deep. For you, it's probably just it's one function in Python. What are you talking about? But in PHP, you basically have to write all these models, all these mathematical functions by yourself. And that was an interesting case for me as a developer, because I don't have just ready to go thing. I have to develop it first and then
Yes, yes.
run and see if it works or not.
Well, when you code in that much detail, you always understand things better. So if you code
I,
every
I, I didn't get the course of statistic at all, but after this lab, basically, I've got how the things works inside and why it works that. That was pretty much good example of how to figure out about the things. If you start exploring basically any topic, you basically need to. I mean, in good good example to find a mentor first. It could be whoever, the person who can answer your probably stupid questions at the beginning, but that is really important so you don't waste your time like weeks trying to understand by yourself. If you can ask and get the answer in minutes, it's much more efficient. Yeah.
Exactly. That example you mentioned with images with numbers, that's like something like hello world in data science world. When you process images, you have to do it with neural networks. So you cannot do that with, let's say, basic machine learning algorithms.
Mhm.
And that thing you mentioned with adding some noise and changing the angles, that's actually data augmentation. And you use that to provide more examples to algorithms. So let's say you have 100, it's too small sample size, but let's say you have 100 images and it's not enough to algorithm to learn something, then you provide more examples by adding noise and changing angles,
Mhm.
and there you have your more examples, and then you push that through algorithms. And now we usually use pre-trained models, so you rarely do 72 hours training or so. You usually just change the final classification layer and you use something that somebody else was training images on. So you have
Mhm.
some typical networks that could process general images trained on really huge databases of images.
Yeah.
But
Uh,
actually, it is the best approach to code everything, each detail, and then you understand everything. But yes, statistics never could be coded in. That's something you must think about it all the time. Otherwise, you will get some results that are not so. You will get just some results,
mhm.
probably unusable one. And then when we are maybe here, we can talk about all that AI, machine learning, data science intersections. So it's not that, let's say, well defined what is what.
Mhm.
But when you talk about data science, you can even talk about things that do not um, involve machine learning algorithms. So with just some statistics, some descriptive statistics, you can do many stuff. You can find some meaningful answers like some mean or median value that might be sometimes useful. You can find outliers. These are some examples that do not fit general, let's say, sample. You can do basic stuff like that. And then if you want to go further, then you use some simple machine learning algorithms. You usually do that just with numerical data. And then you are going maybe to intersection that is still data science, but also machine learning, some more simple stuff. Then, if we are talking about image, sound, voice, whatever processing, then we are again crossing machine learning. It's still machine learning, but we are going into field of neural networks and probably AI. And then we end with AI, which is something that everybody is talking about. So, but in general, that's all like data science in broader terms, where
uh,
you
what, what, what,
combine
what what about big
code.
data? Big data term.
Uh, that
Is it also
would be,
related to data science? Data science.
yes, that thing makes our results better. So the more data you have, the better results you will have, or more reliable results you will have. And if you have big data and know how to deal with it, then you will have really amazing results. Big data would be something, so either too huge data, so some petabytes or whatever of data, or if they are really of different kinds, or something that maybe the simplest explanation would be something that could not fit in a single computer easily. So something which is too huge or too diverse, or
so it's probably
not so easy
some data which decentralized on different machines because it's
yes,
you cannot fit it in one place. Kind of.
exactly, or you cannot even process it with single machine, which is at the end just a technical problem, not that much of machine learning. But then we are entering to data engineering part. The that one is dealing with how to input data in our models. So you do with your data whatever is needed to give the model the data. So it's super simple. When you have some Excel table, then you just import it in your Jupyter notebook and everything is easy. But if you have big data, then you have a lot of things to how to reliably and securely put that data and efficiently, and who knows what.
Maybe you can say a few words about Jupyter book. I've heard it also many times from data science persons, but I have no idea what is that. What a book is that?
Really? You don't use it at
I mean,
all?
I've seen it once, like it's some kind of UI, but what it for? I mean,
There you can easily type your code and execute small chunks of it. You usually come to Jupyter Notebooks by installing Anaconda or Miniconda. You have that white or black window in your browser where you can actually do that experimentation. You type code, you check things, and then you move further. But it's really easy to edit it. So it's like in Word maybe, but you have that chunks, blocks of code. You also have option to, with Markdown, to put inside just a plain text, and that would be it. And it's like really easy for beginners because you are just typing code and you can easily edit it without any worries where it's gonna be processed. Is it okay as a whole? You just
so
type
basically,
it and
this is something like idea for as we have idea for developer. I mean, basically the studio where you develop your code and write everything and can execute it. And this is pretty much the same for data science person, right? Where you can
yes,
just manipulate with your data kind of online and see all these changes at the same moment, basically.
yes. But you don't
Uh,
need any terminal. You don't have to worry how
yeah,
to
yeah.
reach your terminal.
So basically, you just input some data and output some data, and you can probably draw some charts on top of that as well. No.
Yes. You can use, I think, any Python library, at least everything you use in data science world. And then based on what you imported as a Python library, you can do stuff. So whatever you import, you can,
That's
you
nice.
can, yes. And when we are talking about that visual code stuff and
I have
executing, mhm.
I just have million of ideas. I mean, what to develop in sense of not kind of a startup, but some kind of automation for myself, for my family, for some routine jobs, things. But all these things, basically, for me as a web developer, ends up at the moment when you could write all this code and basically go to some point, but then you need this data science thing, which is I'm not really fan of and not really aware of, and that the basically the field where I just stop and think, wow, how it's complex. But you are saying all these things that it's quite easy to understand and basically to start with. right?
Yes, yes, yes. With that code executions, I think we don't have tests in data science world, and I was always wondering what's that. So when you write your code,
Mm-hmm.
you execute it somewhere, but
Mm-hmm.
what are those tests that you are writing?
Yeah, so basically, as in our development world, we have we write code based on some algorithms. I mean, it could be, for example, business logic of some process with, and that process should go that way. And usually, when you write some algorithm, you also, I mean, and then you go to try to test it. Uh, and in most cases, I mean, broadly, developers just try to test uh, the simplest way, the success path, and another way also to test like unsuccessful path. For example, when you try to generate uh, some specific environment around your code before that, and call this code, and then this code should produce some error, and you should analyze this error and basically, I mean, your other software which relies on this function should understand all these errors. And there is also things like when you try to cover some edge cases. Edge cases is, I would say, the hardest one, because this could be anything, right? Uh, which is not really expected by the developer. So something uh, which could be a problem, a bug, basically, which developer left in this code when he was written, and because of he didn't properly think about this particular edge case, uh, it could be a bug inside the code. And tests give us an ability to think from the other perspective on this code. So kind of black box, yeah. So you have some inputs and some outputs, and you try to simulate different situations when something happening in this code inside your function not as really you expected. And this kind of an example of edge case which could happen. And that gives you as a developer a way to find most of these bugs earlier when you write in your code. Yeah, so basically, the thing I wanted to say, tests are quite important right now, especially if you deal with money or deal with, basically, if you write anything, any code. But on the other hand, if you work for a startup, you also need to keep in mind that you don't have all this time to just, you know, write a perfect function and write a 100 tests for that and spend 1 year for these. And after all this time, startup just dead. No, you have to be fast paced, even with errors, but still cover cases and still cover to, some basic inputs. Yeah. And
And
yeah,
you write.
speaking
Mhm.
about tests, there are uh, two kind of tests. So you have an integration test when you test, basically, if you have some API, you just try to call this API, right? And you're expecting some output to be given by this API from this function. And this API could be writing some data to database or whatever else happening inside. You don't really care about this. You care that this interface which your API provides should work and should cover some errors. And another way to write unit tests, when you simply pick small function in your code. It probably could be some sophisticated function or very hard to understand, and write tests for that. So you simulate full environment around this function, what happening inside. You can simulate everything, and you call this function with different inputs. And at the end, you can basically cover many, many different things. and at the end this function don't write anything anywhere, but you can basically do samples of input and output and what should happen during this function.
Seems like writing tests is much more complicated than writing the program.
I I would agree, because when you write a program, you basically see just on the simple thing. Yeah, I have a business task. I want to, I don't know, develop a form on the website, and this form simply should save this data into the database. For example, it's a feedback form, right? But if you start thinking, deeper, but shouldn't we validate all this input? So basically, if someone tries to hack this form from the front end and tries to pass some dangerous data, which probably will break all our database or whatever code, we should check this as well and basically cover. And there is, if you keep thinking, okay, the input is valid now, but there are also tons of bots and other automated systems which could find this form and just start pushing uh, not really expected things in this form, but it will pass the validation. So here probably you will add some captcha solution on the form, so that will break it. Break this behavior. But yeah, write tests is something to. It's also writing a code, but this is kind of a way of thinking. Why do we need QA engineers at all? And in my thinking, software engineer, the person who wrote this code, this person will never ever test this code ideally. Test like with some edge cases, uh, which he didn't expect, because still you think, oh, I'm such a good boy. I just wrote this amazing function. Look at this, and let me just write couple of tests to cover my thinking that I'm a great person. And you are still great if you write more, right? And you find a bug earlier, because bug finally could be some money losing for the company or whatever else, losing data, for example. So that's pretty important. But yeah, speaking to QA engineers, I believe they are very important in any company, and you have to have it, because software engineers just cannot physically test themselves appropriately and understand all the cases, all the bugs.
Do they write code?
For now, for now, basically, QA engineer is a profession which started at the beginning as a person who come to the company and start manually, testing your website, testing your application, trying to write all the, test cases, and try to go through this all the time. But for now, over the time, this started to improve. So some QA engineers started to think, why do we need to manually do something if we could write an automation, basically a program which run all these cases, which put all these inputs and expect some outputs from your program, and we just press a button, go to have some coffee, return back after an hour, and we see the results. We say our boss, hey, it's all fine, or here's the problem, and that's it. So they are becoming now another kind of software engineers, and there is a very broad field, to be honest. But yeah, a bit different thinking, but they also write in a lot of code for now.
Oh. I was also wondering, what about that web development? So what is that web part in the title? You do web applications, but what exactly is that and why it's important? So everything is happening in the browser. With the browser, you have to use some browser or internet or what?
Kind of, yeah. I mean, development at all started, I mean, much earlier to this date, right? And at this time, we mostly what we had just a computer, probably not connected to the internet. But then internet became something like very important in our lives in modern reality. So I don't really see the modern world without this strange connection to the internet because it relies on it. We relies on it, and basically, yeah, at some point things changed because before of that we were developing some software for our computer, and it's been installed on our computer. And the point of this software was probably even working with a database, even remote database. I mean, located on some server. But over the time, we start to realize like why do we need these? Because I mean, uh, I would be happy to run this program from any computer. If I go to work, I run it from work computer, and if I stay at home, I run it from my home computer. And if I'm in the train, I run it from my mobile phone, and it works pretty much same for me. That's the thing when this web part came, and basically it's changed a lot of things. I believe. So for now, the reality is so that I would say almost everything is about web development or maybe mobile development, which is still alive because of uh, you still have another channel of basically installation, but it's really separate topic to speak how mobile application works because they are being distributed in other way, they being sold in other way, and you also need to follow some rules, which, for example, Google or Apple put on your shoulders. If you don't follow these rules, they just delete your application at all, and that's kind of a risk, for, in my understanding. And a point to see more uh, into web development rather than mobile development because in mobile development you still rely on some big corporation which can say yeah, you are not allowed to go here, but you can. And in web you are free. You develop something, you put it out, you could even put it out for free. You don't pay anything for storing it on some server and the stuff. You just pay for the main name. It's free. You start making money. You start doing business, some kind of business you ever imagined.
Perfect. And how do you start with it? There is some stuff like front end, back end.
Yeah, that was, I would say, about 20 years ago.
Okay.
When I pronounce this number, it's kind of shocks me. I'm kind of old for now.
No.
Yeah, but basically, my parents on some day gave me a present computer, and yes, usually I was a kid. I started to explore some video games and played for a while. That was interesting, but I don't know. I wasn't really the person who really sit on in front of the computer and play until the game is finished. I played didn't really like this stuff, so I started to exploring what else I could do on the computer, and that was the moment in school when I started to exploring web technologies, basically JavaScript, HTML, CSS, And I do remember I and my friend built a website, and we create a network between each other through the dial-up connection, very old one, through this, old way telephone line. And then we shared the website through this network between each other. So he made his website, and he shared his website through this network to me, and I shared mine. And then we
Oh,
started to explore basically how networking works. Okay, well, what is internet at all? Basically, this is pretty much the same, but connection is much broader. So you can share not with one person your website, but you can share your website with anybody on this um, network connection. Yeah, so that was a really starting point. And then, yeah, for sure, I went to university, which I was expecting to go to another university in another city, but then accidentally I got a brochure of Saratov State University, and this brochure was saying basically you will learn almost any particular known software engineering skill and language you can imagine during these 5 years. And I looked like that and say, yeah, that's for me. Because I didn't know on what technology I want to be developing in the future. So I just wanted really to get this broader explore this at all. Basically, this is the moment when I studied some data science stuff as well, and other languages like C++ and things like that. And then
and
then you can choose.
where does one starts nowadays?
Where what? Sorry.
With with development. If someone wants to start with web development nowadays, where that one should start?
Yeah, nowadays it's much easier. Trust me, 20 years ago it was more complicated. There was no courses, no books. I mean, there were some books, but the books was like paper books. So you have to go to the shop, you have to buy this book, and you have to read this book. And the difference is so now. I mean, if you need to find some solution or something quite fast, you just go to Google, type it, done. Then back back 20 years ago, you have to read all this book, and then you realize, that was on the page 200. Thank you. 1 month left. Yeah. For now, as I said, there are a couple of good companies which provide even free courses for web developers, for data science developers at all. Yeah, I think pretty much Googling free courses for technology name, you will find pretty much at all of them. Yeah, but as I said, when you're learning, it's quite important to have a advisor on top of you. If you are not completely not from this area, it will be really, really beneficial. You will save a lot of time. So if you think of studying something new in web development or data science, you just I would say find someone on Twitter. There are really, really, really lots of people helping other people to explore this goal.
Yeah, I think it's quite common path after some gaming to enter the developments, let's say that way. And I think there is a connection actually. In those videos games, you always have some kind of reward. So every now and
Mhm.
then, when you finish some level, when you pick up some points, you get some reward. And development or coding, I think produces some similar feelings about it. When it's working, it's like you pass the level in game, or like you picked some points. So I think it's kind of even addictive. So when you
For
When you are,
me, yeah, sorry,
yes, yes.
continue.
So you get your rewards and let's say applause few times per day at least. So if you want some internal reward or you want to get rewarded often, then you code. When each of chunk of your code is working or doing something amazing, you will get that feeling that something is you did something right.
Hmm.
For you,
Yeah, for me, it's not probably about rewards. For me, it's kind of, I also was comparing software engineering to the things like, painting, uh, picture. I mean,
it is creative,
yeah,
really.
it's creative, and the most important thing here that you basically could create whatever you imagine from basically nothing. You don't need, I mean, the only thing you need a computer or even mobile phone to start developing. But it's I would say for me it's kind of a miracle every time I or whatever whoever else creates something. You create a miracle. You create something. I mean, something which could automate, which could help, which could save your time, which could probably be a game just for fun, but it's still some creation. It's it's cool. Yeah, it's really great feeling. Was at the beginning and still for now. But another kind of feeling I also explored on this 20 years path. It's related to open source. Uh, it's really interesting to speak about open source at all because from one basically in one hand you have like you say rewards, and if we speak about rewards, money it's also rewards, right? So you go to your job, you find your job to get rewards in money, and then you can spend this money, or basically one of the reward of software, common software engineer, that you can work from any place of the world. You can sit on the island and work for the company in the United States, which is located in the very, very high skyscraper, but you are sitting still on the island and receiving the payment, which is good for you. And open source, it's something, another kind of feeling when you like kind of volunteering, when you share your time, mostly your time, your experience with others, and because of that, you're also collaborating with others. You could find a lot of people, interesting people to collaborate with, and altogether you could create something amazing. We have many examples of that. For example, Kubernetes. It's a thing for running cluster in infrastructure. It's been open sourced by Google at some point, and it's open sourced for now. And the community driving, moving of this technology forward, and everybody is happy. Everybody is using this technology in many startups because of someone on some day decided to collaborate and share this with everybody. And that's, I think, important. Another important feeling. It pays off. It pays off not with money, but with all this community and with all this support with other people, which also think that it's important. But yeah,
That's also magic. All that collaboration and giving back to the community.
for me it was. I mean, when I entered the open source, how I entered the open source, I've just registered a GitHub account. So fast steps: register a GitHub account, find the problem you have, a really painful problem for you, solve this problem, and share this code with others. If this problem basically shared with others' problems, you will become, you will find others who will start thinking, I had this problem and this guy already solved this problem. Why wouldn't I just use this code and solve the same problem instead of writing my own code? And that's how open source works. You just solve a problem and share this solution with others.
Exactly. In data science, you are also dealing with some problems, and every now and then, when you encounter it, go to Google, GitHub, Stack Overflow, and there's almost always somebody who had the same problem before.
Yeah. And that's another actually good point about web development, JavaScript, for example, because it's a very, very huge community and most of the problems already solved. So if, for example, if you not, if you want to deal with datetime type in your language, you can find really, really lots of libraries already existed, already created and open source by someone, which you can just take and use. And uh, you basically don't spend time on developing these. You spend time on developing something new already based on these old other technologies.
Yes, you're upgrading all the time.
Yeah, that's
Community is upgrading all the time.
okay. I think we have a couple of minutes left. Maybe we can do some wrap up for the
Yes.
listeners. For 0 listeners we have.
I would just like to maybe invite those 0 listeners with any questions might come. So if you have any questions, feel free to ask while we are wrapping up.
Yeah. Well, Mila, maybe you will speak because I already tried to speak.
With this wrap up.
Yeah, sure.
So both data science and web development are huge spaces and really hot places to be entered at the moment. Andrew said, and I must agree, that everything is easier with Mentor. I was the one just wandering around and searching for answers by my own, and it was really painful experience. In both web development and data science, you have plenty subspaces you can really specialize in. And actually, at the end, I think those two really can be combined really well. So at the end, when you have some model, web development is something that with which you can just put that model available for everyone or whatever you have. So some visualization, some data coming in and out. So whatever you do, you need web development to make it publicly available. Open source is quite useful for both fields and something we really support. It's interesting experience to do something with rest of the world, to find people with similar interests, with similar problems, with something similar. And what else? If you are entering data science, you can enter with something simple, like maybe just playing with your tabular data from your Excel. Maybe try to visualize it. And sometimes it's enough. And sometimes you move forward to some simple machine learning algorithm that's certainly enough. But if you want to go further, then you go into that deep learning AI space, or in that, let's say, cloud space, when you monitor everything, when you make different versions of your models, of your databases, make future stores and such stuff. And I would say with web development, if you are starting, it's easier to start with some specific language or just front end or back end, and then to move forward to full stack, right?
Yeah, nice wrap up, Mila. And a few seconds more, I just want to say that if you are looking for her, Mila is our data science mentor for now,
Yes.
and I'm open for any web development questions. If you have any, you just can find our details on the on this YouTube channel, and yeah, hit us. We will reply. Thank you everyone for coming. That was our 1 hour speaking about tech topics. Hope you enjoyed, and see you on the next Sundays.